slides now. This is a t-test. So the t-test, we have three kinds of t-test basically. One is called OneSampleTTest, other one is called IndependentSampleTTest, other one is called PairedSampleTTest. Basically, these are three names used by the different statisticians, but some other names also used by the different statisticians. Right. So when we can use the one sample, I'm just going to brief very fastly. After that, we can go for a demonstration. So I'm just going to, yeah. Yes. So listen, I'm just going to explain the t-test. Okay. So the t-test, the context, there is a three t-tests, as I already mentioned this, one sample t-test, and this is here independent. Second is a independent sample t-test, independent sample t-test, and the third one is a PairedSampleTTest. Okay, these are generally the people using the names about PairedSample. Okay, and just to explain the context when we can use this. Listen, the one sample represent only one sample representation, only sample group, only one sample group. There is no male and female. You can take all, for example, the B.Ed students may sample. Don't divide male and female instead of taking all the B.Ed students as a sample. Therefore, only one sample representation. There is no category like male and female. You are keeping as a one sample. But here, when you use the one sample t-test, as already mentioned, that the t-test is nothing but comparison of two groups means. Compare two means. So the basic meaning for t-test, compare the two means. We need a two means. For the comparison, we are using the t-test. So here, what are the two means needed? One is called sample mean. Here we have the comparison between sample mean with population mean. So hope you understood, because we have only one group. So we have a sample. This sample we are going to collect through the first time, and that's like a primary data. So we may call this a primary data. This primary database, we have a sample mean. And similarly, you can find the population mean, some secondary data. So secondary data, you can find some websites or some kind of official platform. You can find out the secondary data of the population mean. For example, I want to compare the achievements or the I'm checking this one. Okay, learning performance of 12th standard students. Learning performance 12th standard. You are preparing some test for the entire Kerala you are conducting. So that is called sample means. You are conducting the one test. From this, you are getting a one mean. So you are cutting for 1 lakh people or 2 lakhs people. That's a means. Sometimes it will be 70. And the population mean, there will be a database already the last year or the current year the students result may comes. That result we have. So from the 12th standard results, I found that there is a 75 is a population mean. There is a population mean of the entire Kerala. I am taking some sample. I am conducting some tests related to the same learning performance. From this, I understood that my mean is 70. Therefore, we are comparing this, which mean is better, whether the sample mean is better or the population mean. This comparison is called one sample t-test. Here, the comparison between, I'm talking about H0 like null hypothesis. Here, the comparisons between the two means. The one mean is called a population mean, the other mean is called as a sample mean. So therefore, mu equal to m is nothing but there is no significant difference in the mean scores of sample and the population, or there is no significant difference in the population mean and sample mean. Therefore, mu is representing a population mean and m representing a sample mean. Hope any doubts in this, in the one sample t-test? When we can do the one sample t-test, any doubts? We have the two groups. No, we have only one group sample representation. We have the sample mean, parallel we have the population mean. The sample mean, we are cutting the data from the primary data, but the population mean you can identify from the secondary data. Right, now I am moving to the independent sample. Thank you, Vinod. Thank you, Arun, sir, and others. I request all to involve, at least you can respond something.
Pardon, sir, what is the meaning of population mean? Because sample mean is that which we are going to conduct on our own self, by our own self. And population mean, do we have to conduct or what exactly?
No, we don't conduct, madam. This will be available in the data. Okay, that's the reason I'm telling this. Suppose your sample is a 12th standard, right? Right, you are checking the learning performance of the 12th standard. You are conducting some kind of aptitude test or achievement test. So you are conducting for 1 lakh people. Okay, that is your sample. You are conducting the test. From this, you are identify there is a 70. But there will be a population mean. How we can, for example, the 12th standard board examination might be there, right? Through this board examinations, we came to know that that the learning performance of the entire Kerala population is 75%. This is, we can find it from the record, from the secondary data. Therefore, only you have only one sample representation group, that is you are conducting the test, that is 70, but the government conducted one standardized test, that is the mean is 75. Now we are cross checking this, whether this means differ from the population mean. Hope you are getting this, ma'am.
Yes, sir. Yes, sir. Definitely.
Okay.
Thank you, sir.
That is called as normally this population mean you can identify from the secondary data. You cannot conduct any test. You can identify, you can find from the secondary data from the different web sources or any database. And the independent sample t-test. Listen, this independent sample t-test is nothing but two sample. It is nothing but two sample t-test. Why I am telling two sample? Tell me, because this is only one sample. Because you are taking the 12th standard, we are not dividing male and female here. But here, even you are taking as a B8 as a sample or 12th standard as a sample, but we need two basic classification like male, female, rural and urban. Only two classification only two category. So I am just checking here the two groups. I am talking about two groups. I am talking about mu1 equal to mu2. So what is the mu1, mu2? Mu1 is nothing but mean of the male. Mu2 is nothing but mean of the female. So now we are going to compare which means better. Okay, actually in the case of H0 is equal, like there is no significant difference in the mean scores of male and female in the achievement. Suppose I am taking this achievement as a variable. Achievement is a continuous variable. For this continuous variable, I am having the mean scores of achievement and just checking this, whose mean is better. For example, male mean or female means better. That comparison we are using an independent sample test. Therefore, it is called two sample. Here the thing is that two group is needed. Please kindly know this. The two group is compulsory is needed, two sample group representation and only one test. So what is the one test? It is nothing but achievement test. In this case, achievement test or any variable. The two groups nothing but two categories. It will be a male, female or rural, urban or any kind of two classification. Then we can do the independent sample t-test. Any doubts now? Any doubt about the independent sample t-test? Any doubts? Okay, fine. I move to the PairedSampleTTest. So here the PairedSampleTTest, the samples are per listen. The difference is called one sample. This is a two sample. It's called per sample. Basically, we can, instead of independent, you can think about one sample t-test, two sample t-test, per sample. What is called per sample t-test? There will be only one group, but the two tests. For example, the group is one. The group is one. The test which you are conducting two. So the two times test. For example, there is a called pre-test and post-test. So there's a two times you are conducting the examination, pre-test and post-test with the same group. For example, I have the experimental group. So I have the experimental group. The experimental group having the 40 students. All the 40 students you are conducting the pre-test. The same 40 students you are using the experimental, post-test. Therefore, the same sample, writing it to examination, you are checking this, whether the experimental group pre-test scores mean and post-test scores means how it vary to each other. So here the comparisons. Here the H0 comparisons, just writing this, mu1 is nothing but, I'm just writing this control group, I'm experimental mean one, that pretest, I'm just going to, experimental pretest is equal to experimental post-test. I'm using like this, okay, post-test. So this comparisons we are using a paired here because the samples are paired, because the same representation of sample. The same group only writing a pre-test and post-test, therefore the samples are paired, but the test is two. Therefore, it's called per sample. Any doubts? Any doubts? Any doubts, please? So therefore, basically, how many types of t-test? How many types of t-test? How many types of t-test? Three. So
types.
Generally, instead of learning independent, kindly learn like this: one sample t-test, two sample t-test, per sample. Then you can understand the differences. One sample means only one sample representation, and two sample means there's two groups is there. Per sample means there will be only one group, but written by what is that? The group writing two examinations or two tests, right? Selvamadi Sugita, once again kindly check what I'm giving the insight now. One sample t-test, if you need to compare the sample mean, what is that? Population mean. If you want to compare the population mean and population mean with sample mean, you can go with this one sample. For two sample t-test, it's nothing but independent sample t-test. We have the two different groups, but only one test. For example, if you want to cross check the male mean score as a female mean scores, if you want to compare it, we can go with this. In the case of per sample t-test, there will be only one group but two tests. Yeah. Now, if there is a control group which type t-test, listen, Suriya. In the case of experimental method, because when you go with the experimental method, you can use both independent sample t-test, per sample t-test based on the hypothesis, Now I'm just going to read this hypothesis. I request all to type only the one letter. Suppose if it is one sample t-test, you can type O in the chat box. If you're independent sample t-test, you can type I in the chat box. If the per sample t-test, you can type P in the chat box. I'm just going to brief it. I'm just going to pronounce that hypothesis. Based on the hypothesis, you can write this, okay? There is no significant difference between, listen, there is no significant difference between control group and experimental group students in the post test. What kind of t-test we can use it? Tell me. This is an experimental method. There is no significant difference. Please kindly listen. There is no significant difference between control group and experimental group in the post test. Please once again kindly understand my. So how many from my hypothesis? How many groups is there from my hypothesis? Can you tell me? What is my hypothesis? There is no significant difference. There is no significant difference between control group experimental. Therefore, two groups comes on post test. Therefore, two group, one tester. Therefore, what is the tester? What is the t-test? It is called independent. Listen, it is an independent sample t-test. Please kindly note, it is an independent sample t-test. Can you go to the another hypothesis? Are you ready now? So, Adityan, will be there any difference while independence? Yeah, of course, there will be there will be totally wrong. Instead of independent sample testers, if you are using the per sample t-test, the answer may be comes, but the total answer may be totally wrong, and the way you proceeding also wrong. Adityan, hope you understood. For based on the hypothesis only, you can decide whether it will be independent sample t-test, dependent sample t-test. For the survey method, you can go with only two sample t-tests, that independent sample t-test. But the experimental method, based on the so please, I request all to don't be record. Okay. So based in the case of experimental method, it's going to happen based on the hypothesis, both independent and dependent, but you can hear properly that hypothesis. And I'm going to read this another hypothesis. Please listen carefully. There is no significant difference. There is no significant difference between the pre-test scores and post-test scores in the experimental method, in the experimental group. What is that statistic we can use it? There is no significant difference. Harshita, please kindly hear once again. There is no significant difference in the mean scores of pre-test and post-test scores of experimental group. Therefore, how many groups? Only one group, experimental group. But the test is two, pre-test post. Therefore, it's called post sample. Of course, everything's fine. I'm going to read the another hypothesis. There is no significant difference in the mean scores of sample and the population. Yes, Katrina, you are correct. That is called as a one sample t-test. Right. I'm just going to read this another hypothesis. There is no significant difference between rural and urban students in their mean scores of emotional maturity. In the case of emotional maturity. Yes, it is correct. It is called independent sample t-test. Hope you are getting the clarity. You are getting the clarity. Any doubts now? Hope. Okay. Can you move to the next process? Okay.
Sir, paired sample t-test only used in experimental?
Yeah, of course, only experimental. Mostly we are using the experimental. Survey method, we are using the per sample. Because a single sample group, they may be you may be conducted 3 times of interval, 2 times of interval you conduct the test, right? Like pre-test and post-test, or before the experimental one test, after the experimental conduct one test. Like that, there will be 2 interval period to conduct the same test or same variable test, but only one group you are conducting, you can go with this, right? Any doubts now? Right? Okay, now I'm moving to the
Excuse me, sir.
Yes, ma'am, please. Yeah.
Sir, actually, sir, when we are talking about experimental group, what happens is the experiment cannot be just finalized at one test by taking one test or two tests like that. Experiment, see, when we are talking about some experiment in physics or any other science, we perform it very on and on to get certain conclusion. But when we are talking about the same experimental group in the field of research, we are just finalizing it by taking one or two tests. So how far is it going to give us the perfect results?
Okay, but that's based on the research, Okay. Suppose you are measuring the performance of individual in different interval. You can go with 5 times interval or 6 times interval, that's not a problem. But I'm talking about the t-test context. But the t-test context, only 2 interval you are conducting test, then you can go with this t-test. Suppose more than the interval, for example, you are conducting 5 times the different phases you are conducting a examination. You want to cross check how gradually the increase happen. You can go with this called repeated measures ANOVA. For this case, you can use another calculation called repeated measures ANOVA. Hope you are getting this, ma'am. So I'm talking about the t-test context. For the t-test, we need only the 2 means only. That is the reason we are taking the 2 means like a pre and post. Suppose in your experimental, you have more than 3 or 4, 5 or 6 times of measurement you done it, then you can go with the repeated measures ANOVA. You got it? Yes, it's based on the context. It's based on the researcher, based on the research variable. Okay.
Okay.
But the t-test is permissible only for 2 means only. You got it?
Yes, sir.
That's the reason I told only the 2 means. So here the t-test only the comparison between the 2 means only. We cannot go with more than 2 means. If you like to go with more than 2 means, is nothing but ANOVA. You got it? So when you go with more than 3 means comparison, 3 or more comparison, you can go with ANOVA only. Right?
Okay.
Yes, I'm just
Sir, I
moving
have
to...
a question.
Yeah.
I have a question, sir. So I was a little bit confused with this thing. Like if we have two, in the experimental case, if we have the post result only, and we are comparing both the post result for the control group and for the experimental one,
Yeah.
then which test will be used, the paired
Yeah,
one?
but no one. Kindly check how many group is there. How many group is
Two
there?
groups are there. Only the post one we have.
Then what is the test? What is the test? I already told no 2 groups, 1 test.
Two
Therefore,
groups.
it's called 2 groups, 1 test
Independent.
automatically independent. Yeah, based on the
Independent.
hypothesis.
Okay.
Yeah, it's of course an
Okay.
independent.
Okay. Got it.
Independent.
Got it.
Okay.
Okay. Thank
Yeah.
you. Thank you.
Okay, fine.
So
Yes.
one more doubt.
Yeah, please. Fastly because we need to go with the demonstration also. Yeah,
Sir,
please.
we are conducting an experimental research, and we are doing pre-test, post-test, and like that type of one. And if the sample is about 90 or something like, and we are checking rural, urban, or like that. So we have to use both the test or only paired t-test.
Madam, based on the hypothesis, madam, as already mentioned, based on hypothesis, based on the objectives, right? So basically, when you go with experimental method, don't give this importance to the demographic variable. Don't give this much importance to demographic variable because your main intention, your treatment is better or not. Is it correct? Experimental
Yes.
method means you are going to check, your main objective is to check this, that your treatment, whether the treatment is effective or not. That when you go with the treatment effect, what is the need to be look onto the demographic variables as one of the effect. If you want to see this, the demographic variable effect, you can go with this like a 2 cross 2 factorial ANOVA. That kind of ANOVA you can go with this. You can go with the other calculation. Okay, factorial ANOVA. You can check with this treatment as well as the demographic variable, how it's going to together affect the outcomes. That we can check is a 2-factor ANOVA. That's things we are discussing tomorrow, right? But my suggestion that kindly give more importance in the case of demographic variable in the case of experimental method. Okay. If you want to give that, you can go with a 2-factor ANOVA or 3-factor ANOVA. That kind of things you can do this. Okay. Right. So can I move to the demonstration? Yeah. So one more thing, I request all to look onto this because now what's the time now? Okay, 9. Okay, so we have 1 hour time. So kindly see this. I'm just going very fastly that slides now after this weekend. Yeah, this is here OneSampleTTest. We already discussed the difference. The another name is called OneSampleTTest, single sample t-test. Here the discussion that which sample mean with respect to best population mean, and this is an hypothesis. All things I already explained. The independent sample t-test. The independent sample t-test, we have the different names like independent measure t-test, independent two sample t-test, student t-test, two sample t-test. These are the different names. Please, madam, please mute, madam. Madam, please. Rajkumar, can you possible to mute them? It's possible. Okay. Yeah.
I'll check now.
Okay. Thank you. So listen, the independent sample t-test, we have the different name is there. Some are textbook refer, given the different names. And as already mentioned this. Okay. These are the assumption we discuss later. Yeah. Now this is the things you must be aware of it. Okay. And as already mentioned this, if the normality is not satisfying, go with non-parametric. And then homogeneity variance test. This is another one. Particularly is going to help for the independent sample t-test, not for the one sample. And just start with one sample. After we can move to the independent. So I request all to go the yesterday. There's a data set we have, right? There's a data set which you saved yesterday, right? You have yesterday you saved the desktop. There is a data set. Hope you have the data set. You have the data sets yesterday. The data set which you saved yesterday. So hope you saved this one survey data set yesterday. I request all to open this. I request all to open the data sets. Now there is no need to open a Jamovi. When you click this data sets, automatically open a Jamovi because we saved as a Jamovi extension file only. What is the Jamovi extension file name? The Jamovi extension file name. For example, Word documents doc or dox and cx. What is it? The Jamovi file extension .omv. Thank you so much, Preeti and Ilyas. Yes, now I request all to hope you are seeing the same data from your end. So gender, qualification, management, locality, environmental, and green skills, right? And we already defined yesterday one for male, two for female. These are things we done it yesterday. Now I request all to see my demonstration. After that, you can go for further things. Okay. Now you can see this. I'm just showing this one sample t-test with example also. This is a one sample. Hope you are seeing this my screen, right? So here I have the variable. The variable we have environment awareness. For example, the environment awareness which I conducted my end, but there is a population I found it from some of the database. I'm telling this and just find some database. That mean score is 250. The population mean is 250. I'm going to check whether the population mean sample means are same. That is called null hypothesis we are framing. You can see this. You can see the statistical hypothesis. There is no significant difference in the sample mean and population mean. The alternate hypothesis, there is a significant difference in the sample mean population mean. And the null hypothesis, mu equal to 250. What is the mu equal to population mean? Is 250. So in this case, we are checking this whether the population mean and the sample mean is equal. Okay. That's the things we are checking it. So I'm just doing this calculation now with the Jamovi software. Yes. So what is my variable according to the hypothesis? What is my variable according to my hypothesis? Anyone? So you read this hypothesis. What may be variable based on the hypothesis? What is my variable? So what is hypothesis? Once again, you can see the hypothesis. What is my hypothesis? There is, I'm talking about environment awareness. Okay. In the case of environment awareness, therefore my environment awareness is one of my variable I'm taking for doing this analysis. Right. Now we are doing the one sample t-test. Why? We are going to compare with what? Sample mean to population mean. But the population mean I found it from 250 from some net sources. Go to the t-test. So there is no significant difference in EV based on gender. It's an independent sample. Ambiga ma, kindly mute ma. Okay. 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 Fine. Yeah, you can see this. Go to the t-test. I request all to go to the t-test. In the t-test, you will find the one sample t-test. Sir, he is mute. Yeah, I'm trying to ask. Yes, mute. Thank you. So listen, I request all to go with this t-test. Under the t-test, there's a 3 t-tests. One sample t-test, 4 sample t-test, and the independent sample t-test. What may be a t-test more apt for me? What is my hypothesis? There is no significant difference in the mean scores of n. What kind of t-test?
One sample.
One sample, right? Very good. So go with the one sample t-test. When you click the OneSampleTTest, you are getting this data, interface. Now, are you able to see this variable, dependent variable? Dependent variable, what is the format? Are you able to see this? The basic assumption, your dependent variable. What is this? One thing I do, I'm just making a color. Yeah, then you can get this where I'm keeping that cursor. Okay. Yes, fine. What is this? Any idea? What is this? What is this symbol? It is a continuous. Catherine, you are correct. So therefore, this variable should be continuous. The variable which you are going to keep it is a dependent variable continuous. So what is our dependent variable? Environment awareness. Keep the environment awareness. Keep this environmental awareness. Right. So what the test we are going with this? We are going with this t-test. Right. What is called Wilcoxon? What is called Wilcoxon? What is called Wilcoxon rank test? Any idea?
So this is a non-parametric test.
Yeah, listen, this is a good advantage when you use the Jamovi. But when you go with SPSS, we could not know that what is the equals for the one sample t-test non-parametric. But here, when you do the one sample, we can know that what is the equivalence of the non-parametric. That is the advantages we are using a Jamovi. But the SPSS, we can go with the legal fallacy, something is that, then we can find out in non-parametric, we cannot locate easily which is an equivalence of non-parametric. But here we can easily know this. But I'm going to the t-test now. Yes, are you able to see this test value, hypothesis? Right, so the test value is nothing but population mean. What is our population mean? What is our population mean? 250. You can type the 250 here. This is a 250. It is nothing but population mean. You can type the population mean. Now, when you click this, you are getting this answer. Are you able to get this answer now? Are you getting this answer? What is that statistics? 51.6. If you want to know further, kindly click the descriptive. When you click the descriptive, you are getting this answer. Okay. So descriptive statistics, N 1000, mean is 202. Can you tell me why this 51.6? 51.6. So the status is the t-value is t-test, but basically the difference, the difference between the mean difference. If you want to see the mean difference, click the mean difference. What is the mean difference? 47.9. The mean difference 47.9 is nothing but 202 minus 250. So it's taking the exactly number. So it's the comes around 202. But if you go with the decimal, we may get the exactly. For example, I like to go with the decimal of mean. Suppose I go to the number format decimal. When you go to decimal, you are getting this. Are you getting this decimal now? Previously, I had to make the round up. Now you are getting the decimal. Are you able to see this decimal? 202.12. And our test value 250, the difference 47.88. The t value is 51.58. So don't consider the negative value. Why? Why we not consider negative value? Because we are checking this, that mean differences only. We are not checking the directions. Okay. So
Yes,
therefore,
direction.
yeah, therefore, here what you can think, so in this case, you can take this only the value of 51.8. You can don't worry about these, what is that directions like are positive or negative. Take it the difference. Normally that mean one, M1 minus M2 is a formula like a signal. So the difference only. So they may be taking say sample mean first, population mean second. That is the reason 202 minus 250, it is come as a negative value. But basically, don't be considered as a negative value. You can take this as a positive, numerical value only, right? Now, I'm just going to the interpretation part. Kindly see this interpretation of this here. So, how to write this interpretation? Sorry, how to write this interpretation? I'm just going to the interpretation part. Yes. So, yesterday we done it normality test. VG. For the same data, it satisfies the normality based on skewness and kurtosis, right? Yesterday we checked. If you want, you can check this because the normality test is called Safira-Wilk, and you're doing this. And because the Safira-Wilk, as already mentioned, the Safira-Wilk test is not be reliable because that show this it is not be normal. Actually, it's showing us a non-normal because it's like a significant comes. It should be non-normal. Safira-Wilk is not be what is the relevance if you're having more than 300 samples. Yesterday we discussed, right? Any doubts? That's the reason we checked with the skewness and kurtosis. The skewness kurtosis is showing this plus or minus 2 and plus or minus 7. That's the reason we done it. Okay. Yeah, the K-motors will not be showing this Jamovi, but different software is showing this. Here is showing this this one only. Okay, and K-motors is possible with SPSS, but here it's not showing this. Yes, thank you, VJ. Yes, now the next thing, I'm just going to this one, like interpretation. I request all to take the screenshot if you want that interpretation. So this is an output environmental student test. The score is 51.6, degrees of freedom 999 is nothing but n-1. The p-value, listen, the p-value, if you want, you can write this. The p-value, there is a we can make it here three kinds of interpretation based on the p-value, and just write the p-value greater than 0.05. What will be answer? If p-value less than 0.05, like a significant value. If you go with the 0.05 value also, there will be changes may happen. P-value is equal to 0.05. There is a three conditions. We can write the interpretation. So now we can tell this answer. If p-value is greater than 0.05, what may be answer? It's a significant, not significant. The probability value, because now we are using the statistical software, no need to go with the table value to comparison. Table is the old one. We are using software. Therefore, go with the p-value based interpretation. If p-value is greater than 0.05, yes, Arun Kumar, you are correct. It is called non-significant. Not significant. Please kindly note this. Not significant. Not significant means what? The null hypothesis, null hypothesis, null hypothesis, null hypothesis. Tell me, null hypothesis.
Rejected.
Yeah.
Rejected.
No, not significant means there is no significance.
Accepted.
So don't use the word accepted. Statistically, we cannot use the word accepted. So you can tell the fail to reject. Fail to reject. Fail to reject. So listen, statistically, we cannot use the word accepted. Basically, we are reject the hypothesis, fail to reject the hypothesis. Okay, not accept. Accept is a terms we are not, colloquially we are using it. But people are also started to writing, but ethically is not correct, right? Hope you are getting this. Yes, yes. Yes, P less than 0.05. What is that answer? Yeah, thank you, Vijay. You are correct. It is significant. Significant means what? Significant means what? So I'm just putting this null hypothesis fail to reject. Okay. Yeah. Significance means what? Null hypothesis. Null hypothesis rejected. Okay, rejected. Okay, fine. Right, null hypothesis. Okay, failed. No, reject only, Balasubramanian. Okay, so only that null hypothesis rejected or not rejected, failed to reject. So if p value is equal to 0.05, what is the meaning? What is the meaning? It is also significant. It is also significant. Null hypothesis rejected. So these are three conditions. Please kindly take the screenshot if you want. These are three conditions we are writing the interpretation. Therefore, what is it here? What is our p-value? What is the p-value? Less than. Therefore, whether significant or not significant? Kindly type in a single word answer. Is it significant or not significant? Yeah, it is less than 0.01, 0.05 level. Therefore, it is significant. Of course, significant. Is significant means null hypothesis to be fail to reject or reject. Significant means you can type a single letter. If reject means you can type R. Yeah,
Rejected.
it is reject. Of course, rejected. Now we can see this interpretation. One sample t-test was conducted to determine whether the significant difference between sample and population means of 250. The result indicates the statistical difference. Listen, this is an APA format. You have to write this interpretation like this only. This is an APA structure. T degrees of freedom. What is the degrees of freedom in this case? 999. So you have to type like this. T in bracket 999 is equal to 51.6. Why am I not using the minus? No need to use the minus.
Direction is not.
Direction no need to 51.6.
Non-directional.
Yeah, P equal to minus P equal to 0.01. Since P less than 0.05, we reject the null hypothesis. Then concluding that the sample means 202 is significantly different from the
Population mean.
This is an outcome of the what is that OneSampleTTest. Hope any doubts? Hope any doubt? There is no doubt, right? There is no doubt in this case, right? So can you check with this with related to the green scripts now? So kindly remove this. Kindly keep the green scripts now and write. Okay. Sorry, not happening. So can you try with Yeah, sorry. So once again, I go to the t-test, going with the OneSampleTTest. Now I'm just moving to this time's green skills now. Green skills. The mean scores of green skill, just you can scratch it, you can easily to get this. When you go with the descriptive, we won't know this, that mean scores. The mean score is 178. Suppose I am fixed the test value is 178. What may be answer? Tell me. Suppose I am keeping 178 as a population mean sample and so 178. What may be answer may comes? What may be findings may comes? What may be findings? Anyone? How it will be significant? Sample mean and population mean same means not significant. Listen, Vijay, I hope you understood. So population sample means 178. I am keeping population means also 178. Now what's going to happen? You can see this 178. What happened? You can see this output. You can see this output. Its p value is 0.770. Therefore, it is greater than 0.05 level. Therefore, not significant. Therefore, null hypothesis failed to reject. Hope you are getting this. Suppose my test value, my 150. What may be answer? Tell me. Suppose my population is 150. What may be answer? Is significant or not significant? Is significant or not significant? Kindly check. You can do these changes automatically. You may know this. Yeah, of course, it's significant. It is a significant. You can see this significant p value. It's a p significant. Suppose there is a p value. Population mean is 190. What may be answer? 190. What may be answer? What may be answer? Yes, it's a significant. Correct. You are correct. Yes. Now, suppose it is not checking this. It's not satisfied normality. Then what we can do this? What you can do this? Anyone? Suppose that skewness cut is not satisfying normality. Then what test you can go with this? What test you can go? Which test we can go? Non-parametric Wilcoxon. Say, I'm just going to both the findings. You can get the both the findings also. Suppose you want a Wilcoxon, go to only Wilcoxon, right? Suppose you want to get both, you can go click both. So that is the advantages of Jamovi. You may get both output, but the SPS is not possible. If you want a student, you can go this separately, OneSampleTTest. If you want to go with this Wilcoxon, you can go separately. But here we may get the both output. Suppose if you satisfy the normality, you can take the student t-test. If you're not satisfying, give it the Wilcoxon. Hope you are getting this. Any doubts? So I'm just going with the both parametric and non-parametric, and based on the assumption checks, you can go with it, whether you can go with the parametric and non-parametric. So can I go with the OneSampleTTest now? Sorry, IndependentSampleTTest. If you no doubt, can you go with the independent now? If you're ready, you can type R in the chat box, please. If you're ready, type R. I'm just moving to the next one. Okay, next is an R. Okay, thank you, thank you. Yes, now I'm just showing this hypothesis for the IndependentSampleTTest. What is it? Hypothesis? Kindly read the hypothesis. Male students have more environmental awareness in comparing the female students. It is a research hypothesis, but check with this statistical hypothesis, you may get this. What is the hypothesis? There is no significant difference in the mean scores of environmental awareness between males and females. So what is the hypothesis? Null mu1 equal to mu2. What is the mu1 and mu2? Any idea? Why you put mu1, mu2? What is the mu1 represent? What is the mu2 represent? What is mu1, mu2?
Sample
is
of
the mean of sample and population.
Mean of male sample and mean of female sample.
Ah, correct. So male of male and okay, fine. So what is the alternative? It's not equal, right? Now, can we do this calculation now? So hope you are having this idea about the sum, right? Now, what is the path? What is the path? What is the path? And one more thing, listen, for the independent sample test, we have the two variable. One is independent variable, other one is a dependent variable. For the independent, listen, I'm just telling this. Go to the t-test. I request all to go to the t-test. Click this independent sample test. Go to the independent sample test. When you go to the independent sample test, you are getting this interface. You are getting the interface. Are you getting this? The same like SPS or similar interface only. The dependent variable and grouping variable. The grouping variable is nothing but independent variable. So now kindly check it. What is my hypothesis? What is my hypothesis? So can you tell me which may be independent variable, dependent variable according to this hypothesis? Tell me this. Anyone tell me? What may be my independent variable? What is my dependent variable? Yeah, Vijay, you are correct. The independent variable is gender. Male and female is gender is independent variable. And dependent variable, what is my dependent variable in this particular? Yes, environment. Hope you are getting this. So the basic assumption that dependent variable should be continuous. Please kindly note the dependent variable should be continuous and the independent variable should be categorical, but only the two classification, only two groups only. Then only the t-test possible. Please kindly note, I'm just writing this. The basic assumption that the dependent variable should be continuous. Should be continuous. The next independent variable should be a nominal, but only how many groups? Two groups. These are the basic assumptions we have to cross check. Okay, only two groups. If it's three groups, what we can do? If the three groups, what we can do?
ANOVA.
ANOVA, right. So hope you know this. Yes, fine. You are correct. Yes, now we can see this. Yeah, now the dependent variable. Are you ready now? So what may be dependent variable according to the hypothesis? According to the hypothesis, what may be dependent variable? According to the hypothesis.
Gender and qualification.
No. I'm talking about dependent variable according to the hypothesis. Environmental awareness, right? See, these are good things in the Jamovi. What you are finding is dependent variables. You can see this. What is that icon? What is the icon?
Continuous.
What is this icon?
Continuous.
It's a scale variable, right? What about the grouping variable? What is this icon? It is a grouping variable. It is a categorical. Therefore, gender. So this is an advantage of the Jamovi. Can you see the same thing in the SPSS? Did you find this kind of option? That is why I'm telling this Jamovi is like user friendly. The SPSS, even you can put it ulta grouping variable, you put the environment awareness, grouping dependent variable, you're putting gender, the output may comes. But here, even the laymen can understand what may be basic properties of the dependent variable, what is the basic assumption of independent variable, we can get it. Right now, the thing we are getting the student t-test, right? But before that, I'm just going to tell this. Here we can check the homogeneity test. There is one test called homogeneity. The SPSS, how many of them already use the SPSS? Those who are using the SPSS, you can type the letter yes in the chat box, the letter yes. Hope you have the SPSS, you are using it, right? But most of the cases, the people, what they do, no, they will taking the t-test scores of first. But when you see this SPSS output, how many t scores may be there? How many t-test scores might be there? When you go with any t-test, whether only one t-test scores or two t-test scores there. Any idea? Yes, Karthikeyan sir, you are correct. Two t-tests. And which t-test you are taking this? Whether you take the upper one or a down one? Which one you are taking it? Which one you are taking this? Yeah, based on the equal variance as in equal variance not as. But most of the cases, the people are not looking onto this. Actually, that test is called Wilks. There's two kinds of t-test. One is called the Wilks t-test, other one is called student t-test. So, but the take this screenshot now. Now you are getting this. If it is parametric, what you can do this next? You can take the homogeneity variant. That's called Levens test. The test is called Levens test. You can go with the Levens test calculation. When the Levens test calculation, if p-value is greater than 0.05, it is called not significant. Then which test is possible? You can go with the student t-test. Suppose p-value is greater than 0.05, so less than 0.05, it's called significant. So it is a significant. Then you can go with the Wilks t-test. You got it? So the same thing is there in the SPSS, but we are not looking onto this. Just we are taking as a student t-test score, the first one. We are not checking whether it is equal variance assumed or not equal variance assumed. This is nothing but equal variance. For example, not significant equal variance assumed. If it equal variance assumed, go with the student t-test. If the equal variance not assumed, you can go with the Wilks t-test. Any doubts now? Any doubts now? Any doubt? Any doubt? Any doubt? Yeah. If it is parametric, suppose it is not satisfying the normality, then go with the non-parametric. What is the equivalence of independent sample test? Any idea? What is the equivalence non-parametric statistics for the independent sample test? What is it? Equivalence equal independent sample test? Anyone? No. I'm talking about non-parametric. So this is called a parametric only. We can go with both student t-test, Wilks t-test. I'm talking about if it is non-parametric. What t-test? Sorry, what equivalence of t-test? Yes, Malini Rai, you are correct. It's man-made t-test. Now we can see this here. Hope you are seeing this interface. Are you able to see this well test man Whitney? Why the three tests they given? Any idea? Student t-test, well t-test, man Whitney. So when we can do the student t-test, anyone tell me? When we can do the student t-test? When we can check the student t-test? When we can use the student t-test?
When the p-value is greater than 0.04.
Yeah. So in this case of first check the homogeneity. Check the homogeneity. First you can do the assumption check, that is called Levens test. Or you see this Levens homogeneity of variance. What is the p-value? What is the p-value? 0.003. It is
less than 0.05.
Therefore, it is significant, right?
Yes.
If it's significant means what? Equal variance not assumed. If equal variance not assumed, what we can do this? You can go with the
Welch test.
Welch. I hope you are getting this now. Dear participants, kindly check, see my graph. Okay, that is p-value is less than 0.05, then go with the Welch test. If it greater than, go with the student test. This is the things people's not telling clearly most of the cases. I'm just giving this for your purpose, because the SPs also there is two output, but the people are, for the name check, they're taking the first one. They're not checking whether it will be equal variance assumed, not equal variance. That's a problem. But hereafter, kindly check this. First, go with the assumption check. And if it more than, if it is significant, go with the Welch test. If it's not significant, we can go with this Man-Whitney. When we can use the Man-Whitney? When we can use Man-Whitney? When you can do the Man-Whitney? Non-parametric.
It is not normal.
Yeah, and just see this. This is an advantage of here. I'm generating the three output. Are you able to see the three output together? Are you able to see the three output together? Student t-test,
Yes.
Welch t-test, Man-Whitney. This is possible with the SPS. Is it possible? And you can fairly know that what is the equivalence of the student t-test. The equivalence of student t-test, Welch test is there, and Man-Whitney also there. But these are the things we cannot learn from the SPS, because the SPS is not that much of user-friendly. But here, everything we can learn is like a student-friendly base. Okay. Hope you are getting this. Yes. Now you are going to write the interpretation based on the previous. Can we go with only the for this case, which may be correct? Anyone tell me which may be correct? Your p-value is 0.035, 0.30. Therefore, the homogeneity variance not assumed. Then go with this Welch test, right? Welch test. What is the answer? T-test 1.11 and 287.77, 0.269. You can write the interpretation. Suppose you want a descriptive output, where you can click the descriptive, you are getting the descriptive. You are getting the descriptive. So you are getting the same like SP is male, female, N mean score, median, SD, standard error. Suppose you want the means difference, go with the mean difference. What is the effect size? Any idea what is the effect size? What is the effect size? What is the effect size? When we can use the effect size calculation? Only for experimental method we can use it. Suppose you are checking this, you are seeing this control group or experimental group better than the control group. But we are talking about the hypothesis in the effectiveness format. So intervention, right? Of course, you are correct, Vijay. When you go with the intervention like experimental treatment, check with this effect size calculation. Only for the experimental method you can use it. So what is the advantage? When you click this effect size, you are getting the cogensity value. From the cogensity value, we are writing the interpretation, because the cogensity value is talking about the effect size, right? If it less than 0.2, it is called low effect. 0.2 to 5 is called moderate effect. More than 0.5 is called high effect. So this is a way we can write the interpretation whether the treatment is low effect, moderate effect, high effect. Yeah, Appreciate Korea has already mentioned this. Man-Whitney test is nothing but non-parametric. If your skewness and cut is not satisfying the that basic assumption, go with the non-parametric. Go with directly Man-Whitney. So what is a Man-Whitney? You can see the Man-Whitney test. You can check this p-value. So once again, go the p-value. The p-value. What is the p-value response? Is significant, not significant? Is significant, not significant? Anyone? Is significant or not significant? P-value. P-value 0.292. It is greater than 0.05, therefore so not significant. Not significant null hypothesis. What is the condition? Null hypothesis to be failed to reject or reject? Null hypothesis. Null hypothesis failed to reject. So what is the findings? What is the findings then? What is the findings? What is the hypothesis? What is the findings? There is a significant, sorry, there is no significant difference in the male and female, the mean scores of environmental awareness. So I'm just going to keep all the three. How can we write the interpretation with cogents? Catherine, there is an cogents, there's a formula is there. If it less than 2, I mean 0.2, it is less than 0.2, it is called low effect. 0.2 to 0.5 is a moderate effect. 0.5 above, it's called high effect. So in this case, suppose if it is experimental method, I'm just telling this. If it is experimental method, what is the condition? Tell me. I'm just thinking it's the experimental method. Effect size. What is the effect size? What is the effect size?
0.09.
0.9. What is the meaning? It is zero effect. There is no treatment effect, right? It's near to zero. No, it is zero effect.
Low.
Zero effect. There is no effect at all. Okay, because it's not experimental data. That's the reason showing that it's coming like this. Okay. Sorry. Yeah. Now one more thing. Now the question, very simple question. Can you give the answer based on the output? So now student t-test, well t-test equivalence of the effect size is called congruence rate. Now the question, man-Whitney equivalence, what is the effect size formula? Which formula we can use for the effect size calculation for the non-parametric statistics? Particularly man-Whitney you are using it. What may be appropriate effect size is needed? What is the effect size formula we can use it? Any idea? Hope you are getting this. For student t-test, the effect size is called congruence rate. For the well t-test also, there is a congruence rate. For the man-Whitney u-test, you are doing it for the
Rank by serial.
Yeah. So how we are finding this? Where you are finding? You can see this output. What is the output? Rank by serial correlation. This is an advantage of Jamovi. Even the laymen like us, any person can know what kind of appropriate studies is possible for this particular data or for particular parametric, non-parametric. Hope any doubts? Any doubts now? Any doubt? Can we see this interpretation now? Yes, I'm going to interpretation. So kindly see this interpretation. Okay. So first, what is the test? What is the homogeneity? So what is the p-value? 0.035. Then independent sample test. We are in this. This is a descriptive. So what I wrote here, a Levin test equivalent variance indicated the variance between the groups were not equal. F1, this is in 199. What is it? 1998. Any idea? What is this? 1998. Why I'm putting F? Because we do the t-test. But why are you using the F?
Degree of
the
freedom.
t-test. Why I'm putting F instead of a T? Very simple. You can see this. What is that formula? Homogeneity, Levin's test. What is the score? Actually, it's a F test only. The score is of F is 4.46. The degrees of freedom 2 is needed. Between group, within group. The between group variance 1, between group variance 992. That is the reason they put 1, 998. That value is 4.46. P value is 0.35. P greater than this. And we reject null hypothesis variance. However, the independent sample test showed this one. And the T degrees of freedom, what is the T score degrees of freedom? It is 998. And the answer is 1.16. P value is 0.245. I think P value is 0.245. The P is greater than. We failed to reject the hypothesis. The indicating that the mean environmental awareness scores for male and female are statistically is equivalent. It's in the there is no significant difference male and female in the environmental awareness. Any doubts now? Any doubts? Any doubt? Any doubt? If there's no doubt, you can type at least 8 in the chat box, please. Yeah. Thank you, Vinod. Please, I request all to interact with me. Okay. Yeah. Fine. So now, can you give this one hypothesis? Can you do this sum and kindly tell this answer? Give this that findings. Are you ready now? So now the hypothesis for this this one. I'm just going with this Jamovi. I'm just going to read this hypothesis, but you have to do this calculation. The hypothesis like this. Please kindly know the hypothesis. There is no significant difference in the mean scores of green skills attitude with respect to the qualification. With respect to the qualification. Hope you are getting this. What may be independent variable? There is no significant difference in the mean scores of green skills attitude with respect to qualification. What is maybe independent variable? What is my independent variable?
Qualification.
Yeah, qualification is independent. Dependent variable?
Green
Dependent
skills.
variable?
Green skills.
Green skills.
Green
Now,
skill.
how to do this? Go to the t-test, independent sample t-test. So dependent variable, green skill, independent variable, qualification. Now kindly check which may be apt statistic, whether it's a wealth test or student test. Kindly tell me which one is better. Go to the homogeneity test and check the homogeneity first. When you click the homogeneity, that findings comes. Yeah, now you can tell me which may be a appropriate statistic, whether it's a student test or wealth test. Which one is correct? Why student? Why is Arun Kumar? You are correct only. Please, if you possible, turn on, unmute and talk to me. It will really help for the other people also.
P's value is greater than 0.05.
Yeah, it's correct.
So we have to go for student
So
test.
VJ, it's not parametric, non-parametric. Don't be confused. Parametric, non-parametrics depends on the skewness kurtosis. Here I'm talking about homogeneity. Based on the homogeneity only, we are checking with the student, because wealth test as well as student test is a parametric only. You got it, VJ? Both the tests, student test, wealth test, both is a parametric only, right? Both is a parametric. Kindly understood. Okay, thank you. But man-meeting test is a non-parametric, right? Yes, now in this case, we can go to the wealths. Therefore, click the wealths. What is the interpretation? Can we tell this answer? What is the interpretations? P-value is 0.0018. Therefore, what is the answer? Whether the hypothesis fail to reject, null hypothesis, or reject. What is the hypothesis? What is the hypothesis? There is no significant difference in the mean scores of
Rejected.
green skills with respect to qualification. It is rejected. Then what is the exact finding? Is rejected means there is a significant. Then how we can tell this which group is better? Go to the descriptive. When you go to the descriptive only, we can find this. Then you can tell this final output. You are telling this it's rejected. So what is what is that finding? There's a significant difference in the mean scores of green skill with respect to the qualification. Now the questions here. Now the questions. What is the final findings? What is the final findings? You can check with this. What you can check? From the mean score. Whose means better? Whose mean is better?
Green skills.
No. Whose means? UG. UG's mean skill. Okay, 179 is a means of UG. P is 172. Therefore, the final interpretation is that the UG students have more mean scores in the environmental awareness than the PG students. Major findings. This is a perfect finding. Hope you are getting this. How to write this? How to write this?
Yes,
okay.
sir.
So some other things, these are things, this. What is a group 1 greater? This is called as an, normally this is basically two kinds of hypothesis. One is called, one type test, two type test. We are using the two type test because we are using the non-directional. This is called direction hypothesis. Group 1 greater than group 2, group 1 less than group 2. If you go with this direction hypothesis, the findings may be changed. You can see this. This is called the non-direction hypothesis. Therefore, findings may be changed. So you can see, suppose you are making a non-direction hypothesis, like a control group is better than experimental, experimental better than control. You can go with the non-direction hypothesis. These are the things is available in Jamovi. SP is also there, but I don't know how many people have viewed this. We can select this, whether we like to go with the OneSampleTTest, tTestTutorial with this. So can you go with on next level calculation? I hope no doubt, right? Don't know any doubts, right? Yes, can we go with this one? I request all download with this data set. There is a data set which I shared yesterday in the. So I request all to go to the yesterday. There is a link which I shared now, but yesterday I added some more files here. I go to this database. Yesterday we shared one drive. No, don't go with this yesterday's, because the problem I uploaded today some data sets extra. Therefore, I request all to click this link, the Google Drive link. Click the Google Drive link. Click the Google Drive link. If possible, I'm sharing this Google Drive link once again. Okay. So I'm just sharing this Google Drive link of the last yesterday. Yeah. So I'm sharing this link, the Google Drive link once again. I request all to click this link and go to the this one, data sets demonstration. Data sets demonstration. Then click download the third one. Download the third. Sorry, not fourth one. There's a fourth data set. Sorry, I'm just opening this directly. This one. Go to this one, and I request all to download this one. A fourth one. Are you able to see the OME file? Are you able to find the OME file? OME file, not in the Excel file. OME file I request to download because I already described the male and female, sorry, control group experimental. I request all to download the OME file of the number 4. After download, you can type D in the chat box, please. I request to download and type D in the chat box. Then after done. So Catherine done it, Katrin done it. What about others? I request all to download the OME file. OME file is directly is Jamovi file, so it's easy to open. So now I request all to open this file. I request all to open. That is experimental treatment base. So I'm just yeah. Amen. So this is a data set. Yeah. So those who are open the data set, you can type O in the chat box. I think someone shared the screen. Yeah, I request please stop sharing. Someone's unknowingly they shared. Who shared the screen? My screen visible? My screen visible to all of you?
Yes, sir.
But I seen some other people's screen in my mobile. Yeah. Yes. So I think, sir, please can you stop sharing? Someone share the screen unknowingly. Okay, and just stop sharing and sharing once again. And stop sharing and sharing once again. Yeah, is it visible now? I think who's sharing the screen? Sir, yeah, now you're getting the new screen or another screen. There is a person. I request all to stop sharing. Someone share the screen. Bharat typist. Okay. I request the person please kindly stop sharing. So I'm just checking who's. Who shared the screen? Sri Lakshmi? No, Sri Lakshmi. Who shared this? Some people unknowingly share this via WhatsApp.
Somebody called Balamurugan, sir.
Balamurugan, sir. Sir, Balamurugan, sir, can you stop sharing? Because sometime, no, my display not be visible to others. Can you stop sharing? Can you stop sharing? Yes. One minute. Rajkumar, can you, I think you are the host now, kindly check how to remove this Balamurugan sir's sharing. Okay, if possible. Balamurugan share the screen. Because sometime when sharing also is not visible. Okay. Yeah, some people are opening. Balamurugan sir, a lot of people are sharing the screen now. Other screen also is coming for me now. Okay. Please, I request all to stop sharing, please, please. Otherwise, yeah, I think they stop sharing. Still Balamurugan sir. Okay, I'm just sharing this. If possible, you can remove the Balamurugan sir. You can when he join, you can allow him. Okay, sometimes
Yes, sir.
he might
Yes,
not
sir.
be know how to do.
Sir, I am Balamurugan, sir.
Yes, sir. Sir, your screen is visible to all of us. I mean, now it's okay. You removed, no, sir? Sorry, you stop sharing. Yeah. Yeah. I think it's okay now. I hope all of seeing my screen now. Jamovi screen. Is it visible?
Yes, sir.
Yes,
Yes,
sir.
sir.
Okay, sorry. Okay, please. Okay. So I request all to don't share because sometimes unknowingly maybe share. I know this. So please don't share because sometimes my screen not be visible to others. Okay. Now I hope you are seeing this kind of display.
Just wait, sir.
Yeah. I request all to open this. Are you able to find the filter option? Are you able to find the filter? In your case, filter is there.
Sir.
Yeah, Balamurugan sir, please. What is the doubt? Balamurugan sir?
Yes, sir.
Yeah. Any doubt, sir? Yeah.
No, Doctor.
Yes, fine. So, are you get this same filter option? Are you find the filter? You have the filter? Anyone's find whether you have the filters? Same filter is there? Yeah. So one thing I request all to delete this filter first. So I request all to go to the data view. Okay. Go to the filter. Go to the filter. Go to the data and filter. Remove the filter first. Okay. Go to the filter and remove the filter. Remove the filter. So close all. Now we are seeing this all the data, right? How many the remove the filter? Those are remove the filter. I can type R in the chat box. Kindly remove the filter first. Okay. So the sample spelling wrong. If you want, I can change the spelling of sample. Okay, and change this spelling of sample. Okay. Okay, fine. Listen and close it here. Hope you are getting this the tool. I mean the data, the control group, experimental. So how many sample totally? 44 sample. It's in the 22 experimental, 22 control. The pre-knowledge, pre-understanding, post-application, pre-total. Therefore, how many times they conduct? How many intervals they conduct the examination? Any idea? How many times they conduct the measurement? The 3 times. So post total is that, and post delayed also there. Therefore, the 3 times that deleted post, the 3 times they conducted according to the study. And there is a gender, these are things, just keeping this because sometimes you want to do the 2-way and all, that's the reason I kept it. Hope you are having the doubt. You don't have any doubts. Now, I want to do a independent sample test for this case. So how to do this? Okay, how to do this? Don't confuse with the output. So you can, yeah. Now I request all to go to the analysis. Go to the analysis, go to the t-test, go to the independent sample test, go to the independent sample test. So when for this experimental method, when you go to the independent sample test, if you have the 2 groups, if you have the 2 groups, 1 test, is it correct? 1 test, 2 group. So here I'm taking the post test. I'm taking the post test. I want to check the post test. Suppose I want to know all the tests. You can see, you can keep all the tests. At a stage, you may get the pre-knowledge, pre-understanding, these are the dimensions, pre-total, post-knowledge, post-understanding, post-application, post-total. You can put all the dimension with the score. And the grouping variable is a group. Keep is a group, control group experimental. Now we are getting this output. Now we are getting this output. This is an output. Yeah, you get this wonderful output and check the homogeneity and check the homogeneity also. So when you check the homogeneity, in all the cases, except one case, we can go with Wilks, but sorry, 2 cases Wilks, other cases student t-test. Is it correct? For all the cases, what is there? Pre-knowledge, we can go with the student t-test, pre-understanding student, but only the case pre-total and pre-knowledge, we can go with Wilks. That's the reason I just select both. So we can get the 2 output at this stage. Are you able to see the 2 output? You can go with this normality also. Go with the normal, sorry, not normality, descriptive. Effect size also. I'm just selecting this effect size. You're getting the wonderful output now. Now effect size also. Now, anyone's tell me for the pre-knowledge, we are taking the student t-test, whether that significant or not significant t-test. T-test significant or not? I mean, in the case of pre-knowledge, is significant or not significant? Significant or not significant? Anyone?
Pardon, sir, please.
Now the pre-knowledge, the knowledge level, that P-score is significant or not significant? It is not significant, of course.
Not significant.
Right, pre-understanding not significant, pre-application not significant, pre-total not significant. What about the pre-post knowledge? What about post knowledge?
Significant.
Significant. You can see this effect size. You can see the effect size. You can see this experimental of the post level, the treatment of post level. All the cogents value is more than 1. Is it correct? Is more than 1. What is the meaning? What is the meaning? What is the meaning? The cogents D value, as already mentioned this, more than 0.8 above, it is high effect, large effect, high large effect. Effect size high large. 0.5 is large, but if more than 0.8 above is so high, it's like more high. So you can use the term is like a high large effect for the treatment. So this way we can write the interpretation for the t-test in the experimental method. Any doubts? So whether I done independent sample dependent, I done independent because the hypothesis like this, there is no significant difference between control group and experimental group students in the pre-test. Similarly, there is no significant difference in the control group experimental student in the post-test. That's the reason I done it at a stage. Hope you know this, when we can use this student T, when we can use the web teachers. Any doubts? Can you go with the PairedSampleTTest now? Can you go with the PairedSampleTTest? Can we go with the PairedSampleTTest? Yes, fine. So anyone can brief it when we can use the PairedSampleTTest. Which condition we can use the per sample? When we can use the per sample? I'm taking 10 more minutes very fastly. When we can use the
there
per
is
sample?
only one group and
Yeah.
two
Now
test.
I'm just doing the per sample. Now you can tell whether the answer is correct or not. Are you ready now? I'm just going with this. I'm going to the per sample. I request all to click the per sample and click the per sample t-test. See this, what is that variable? It should be a continuous. But we have the two groups. You can put equally. Pre-total, what is the equal of pre-total? Post-total, right? So automatically the pre-total post-total may comes, the output may comes, right? And go to the descriptive. I'm checking the effect size. Now you can tell me whether the finding is correct or not. The finding which you see is correct or not. It is a PairedSampleTTest. We done it a PairedSampleTTest. So what is my hypothesis? I'm just studying the hypothesis. There is no significant difference in the mean scores of pre-test and post-test means pre-test post-test mean scores of experimental group. This is my hypothesis. Whether the hypothesis correctly I done it?
No.
Why? What is the wrong in this?
There is a lot of difference in the mean.
Mean is different. No, the mean difference automatically pre-post automatically the post scores might high number. It's not a mean score difference. There is a logic missing. What is the sample size? What is the sample size?
44.
What is my control group sample size?
Control group.
How to go this? Click this here. So when you go back here, you can see this. What is the control group? Number of control group? 22.
22.
Experimental? 22.
22.
But here you can see the findings for the 44 people. Is it correct?
No.
Therefore it's wrong. Is it correct? The same thing is there in the SPS also, but the people are doing it. The SPS also we need to be filter, or we can be divide control group experimental group and just go introduce the filter concept. Then only that output may be correct. So I'm just introduce the filter. Why? In the sense, at default, all the 44 samples taking consideration when you do the analysis. Hope you are getting this. All the 44 samples taking, but according to my hypothesis, I need only the control group, or I need only the experimental group. So how we can do this? We need a filter. So how to do the filter? Kindly check my display. So I'm just introducing the filter concept. Go to the data, go to the data, go to the data. So there is a data. Are you able to find the filter? Click the filter. So what is my filter means? I want to take the group, only control group for one time. The next time when you do the calculation, I want to take it experimental group. Okay. So listen. So here the filter, you are getting same interface. The group, how we are typing, see this, how we are defining the group. The group G is a capitals, R U P is a small. You can type same as it is group, GROUP. Please kindly type same as it the variable name. I am keeping the group as a variable name and give you one space. 2 times you can give equal. Keep 2 times equal and put 1. What is called 1? What is called 1 in this case? What is called 1 in this case? Any idea? 1 represent control group. 1 represent control group. Yeah, so I am already give this 1 is a control group. Okay, according to this. Okay. So therefore go the filter. Go the filter. Sorry, once again. Go the filter and group equal to 1. Automatically the control group is to be selected. Okay. Now you can see only the control group is visible, right? Experimental group is closed. Is it correct? Is into mark, right?
Yes,
Therefore, whenever you're doing the calculation, you are getting only output for which group only?
22
control
control.
Group. Yeah. Now I request alt one more thing. So go to the filter. Go to the filter. Now the group 1, you are keeping 1. So go to the plus symbol. Go to the plus symbol, and once again go to the group. Group equal to 2 times equal to. Give the 2. What is the meaning? What is the meaning? It taking only
Experimental group.
Experimental group. But the problem, both is active now. Both is active. So now my hypothesis like this. There is no significant difference in the mean scores of, in the pre-test post-test scores of control group. Therefore, which group I'm going to check? Only control group. So what you can do, remove this active. So in the active, kindly remove it. I request, because I need to go with only control group. So go to the filter, remove this active. Don't be close, only remove this active and go back. How many of them done this? Those are done, you can type D in the chat box. Now you can see this, how many sample only selected? How many sample only selected? 22. Now you can see these findings. How many sample findings there? Take this
22.
findings.
22.
How many sample findings? You are getting how many sample findings?
22.
22 sample. This is a correct output. Hope you are getting this? The correct output, this one only. What is the correct output? So
We
this
have
is
to
an
apply
correct.
filters.
Yeah, this is an correct. Exact output. What is the T score? 22.93. What is the effect size? 4.8 times more effect. And just showing this interpretation for you. This for the control group. How to go to the experimental method? Any idea? Suppose I want to get the experimental data output. What I have to do? I want to get the experimental output.
We have to go and click on active for the filter.
Filter where,
Active
yeah.
for
First
the
deactivate the group 1, okay, and activate the group
experimental group.
Yeah, now you can get this the same different output for the experimental group. Hope you are getting this. This is an output. I'm just showing this interpretation. I'm showing the interpretation. Please kindly take the screenshot of the interpretation if you need. Sorry, where is the interpretation? Yeah. So this is an dependent sample t-test. What is that hypothesis? There is no significant difference in the mean scores of pre-test and post-test scores of the experimental group, right? So what is the per sample t-test? 39.14 and 0.4 DEF is okay, and the mean difference okay. This is SC. The p-value is, what is the p-value? Significant or not significant? The p-value.
The
P-value?
The p-value is significant.
Less than 0.05. It is
Less,
significant.
yeah.
It is significant, right? It is significant. Therefore, hypothesis rejected or not rejected?
Rejected.
Yeah. Therefore, what is the findings? What is the findings? There is a significant difference. Then you can check this. Which mean is better? Which mean is better?
Post-test.
Then you can write the post-test, post-total scores, mean score is better than the pre-test scores in the case of experimental method. You can see these findings. The post-sample t-test was conducted compared to the achievement. The mean is 112.4 and post-test mean is 34.4. The degrees of freedom, the formula is n-121. 39.4, p-value is less than 0. Given that p-value is less than 0.0 significant, we reject the null hypothesis, indicating this significant improvement in the achievement scores after the intervention. Right? So hope you're getting this, how to write this things for the experimental method. Right? Can you give us one hypothesis? Can you do this? Right? But you can tell this directly because we already done it for pre-test. Okay. Now, can we do the same time for the this one? For example, you want to do for the pre-knowledge, like all the dimension you want to do this. Can you do attest touch? Is it possible to attest touch for the experimental group? Is it possible? So now we done it only for pre-total and post-test. Suppose you want to do attest touch for all the dimension. Is possible now. So very simple. Go to the analyze. Go to the analyze. So go to the t-test. Per-sample t-test. You can go with the parallel. Okay. So pre-knowledge. What is that parallel? Pre-knowledge parallel. Post-knowledge. Pre-understanding parallel.
Post-understanding.
Post-understanding. Keep it like this. Pre-application. Post-applications. Pre-total.
Post-total.
Post. Therefore, you can done 4 statistical attest touch. You can get this wonderful outputs here. Descriptive, effect size, which are things you want, you can select it here. Right? So now we are getting the 4 output. So it's emerging. Are you able to see this 4 output? This for the which group? Is a control group or experimental? It is an experimental. If you want to go back the control, what we can do? Go to the filter.
The filters.
Yeah, go to the filters. Okay. Yeah. So hope you don't have any doubts in this. So what is it? P-values telling here?
It is significant.
All the dimension as well the total is significant. Therefore, who is better? I mean, post-test scores are better than the pre-test scores in the control group. It's an experimental group. Right. Now, suppose it is not set in the normality. What test is equal? Now we done a paired sample test. What is the equivalence of the test? What is the equivalence test? What is the equal non-parametric?
Wilcoxon and
Yeah, see this automatic Wilcoxon. Select the Wilcoxon. You are getting both. Are you able to see this? Wilcoxon, what is that effect size? Rank by serial. So therefore, based on the assumption, you can select whether it go with a student t-test or paired sample t-test or any Wilcoxon. And just generate both, but you can select which one you want, right? Hope we don't have any doubts. Any doubts?
We need
Any-
this, very frequently. We should be aware of this, and we need to have it on our hands working on this. Just one session, sir. It's not going to be sufficient for
Yeah,
us.
that is why. So we are
Yeah.
giving the time for today night. Okay, I request I am giving the two different data sets. I request all to experience because today attending if you are not doing regularly, you may forget. Even if you attend 100 workshop also, every time you may hear the new one only, right?
Yeah, we need some more workshops
Yeah,
like this.
you need to be you need to practice by yourself, right? I request all to practice. The practice only makes perfect in the case of research. So I request all to practice by yourself. It's going to help you a lot. Right. So can you go with one way ANOVA very fastly? Can you go with one way ANOVA? Because we finished all the t-tests. Independent sample t-test, PairedSample t-test, one sample t-test. Is it okay? Now we can go to ANOVA tomorrow. Okay. We can wind up now. Okay. Tomorrow we can discuss about ANOVA, right? Because tomorrow we are talking about two-factor ANOVA, three-way ANOVA, everything we discuss tomorrow. Now, can we stop with this?
Yes, sir.
Okay, any doubts? Any doubts up to now? So, can I ask some questions? Kindly give. What is the equivalence of the independent sample t-test in the non-parametric? Equal non-parametric test for the t-test. Man-made t-test. What about the one sample t-test equivalence? What is it? No, I'm talking about one sample t-test. One sample t-test, not man-made me. One sample, if you have doubt, just go with the one sample. You may get this idea. So what is the one sample t-test? Wilcoxon rank, right? So Wilcoxon rank. So like this, even if you are not having time to be learn this, kindly experience this Jamovi how to you maybe get some idea. Kindly tell you about the homogeneity normal difference. Sir, homogeneity, it is part of the parametric test. Galaxy tab, okay. Normality check based on you are selecting whether we can go with a parametric and non-parametric. Once you done a parametric, go with the homogeneity check. If the homogeneity check is satisfying, like it is equal variance assumed, then go with the student t-test. If equal variance not assumed, go with the Welt test. Because Welt test as well as the student t-test both is a parametric. But man-made t-test is a non-parametric. Hope you are getting this. First context, you can check the normality. If you check the normality, it's satisfying the normality, go with the parametric. If you're not satisfied in normality, go with the non-parametric statistics. Go with directly the man-made or Wilcoxon test based on the context. Okay. Yes. Hope any doubts. There is no doubt in this. Suppose we want to know more about t-test. I'm already made a small added in the yesterday slide itself. If you go back to the yesterday, I shared one link now. I added some more reference for you. Go to the so when I go here, you can see this. Yeah, this is a t-test. I already, sir, you're asking the parametric, non-parametric. I request all to go with this link. When you click this, we are getting wonderful resources. You may get some kind of insight about what is the difference parametric, non-parametric. And this for the t-test, different t-tests, how to write the interpretation, everything is there for the t-test. So kindly check this two reference article. You get, this for the article only. So I'm just refer some of the good article related to the different statistics that I'm suggesting for you. So kindly go through this. Okay. Yeah. So there is in questions. You're asking this one. Okay. This slide. If possible, take a screenshot. This slide is giving some idea for you. Yeah. Take the screen photo. So if it is a normality check satisfied, parametric, not non-parametric, in the non-parametric go with a mad mediators or anything.